and then I'm coming over here. Doing the same. All right, so you'll notice I'm joining in. Show my screen. Okay. Somebody maybe has sound on. All right, so are we ready to actually pick up where we left off? Like literally in mid-April, I believe I told you all, we're literally cutting the material off. Like this is where AS Chem ends, and then A Chem literally picks us from where we left off, which we were in the middle of acids and bases. So we're going to have to review some things. Let's talk about schedule, what's coming up. So you may or may not have been told yesterday, I'm pretty sure that I didn't tell you, that on Tuesday, seniors will be having their orientation to the school with Miss Sanz Gomez at 7:30 a.m. for at least an hour. Yes, go ahead, Peter.
So aren't they already oriented?
There's a lot of senior stuff. They have senior picnic. They have senior photos. They have the senior trip. They have like a big senior trip. There's a lot of things to be went over, and she's gonna have some really cool things to share with them. So it's important that they're there. Now, this class is approximately half seniors and half juniors, which means that I will not, while the seniors are out, be able to teach a lesson. And so we will be playing some games, you know how we like to do on what we've learned today, for those of us that are here, the juniors. Yes. As soon as Axel comes back, he'll be next. I just wrote him a pass. He left about 2 minutes ago. So I'm giving you that heads up, meaning that I was able to schedule the assignment to post for today, but it's not going to be due until Thursday to give time both to start the lesson today. If we don't have enough time to finish it today, we will finish it on Tuesday after the seniors get back. But it's actually not super long of a lesson. I did add a few extra questions that were Cambridge questions that makes it a little bit more amplified. But usually I try to start light, but I'm going to now tell you, you need a calculator for today. So if you don't have your own calculator, please feel free to come up here and borrow one of mine. It is what we did in pre-8 mostly. But, okay, some people didn't take pre-8s, and for some people it's been a while. So get a calculator. We're going to go over pH formulas. All right, so standard strategy for the lesson. I'm going to go solve questions. Then there's going to be some questions that say your turn. That's your responsibility to try. At this time, I do need your attention. So let's go ahead and get started. You can see objectives. I know you're so very excited. Understand and use the terms conjugate acid and conjugate base. Put a check mark if you remember those things, and an X if you don't. Because technically, we did go over that in AS chemistry, and we did go over that in pre-AS chemistry. So this is actually the third time we're going to be going over this topic. So I like to start here because we went over some of this a lot already. The next, define conjugate acid-base pairs, identifying such pairs and reactions. So the acid on one side becomes the base on the other, right? We'll be going over that. Calculate H+ and pH values for strong acids and strong alkalis. Welcome back. All right. Yeah, you're supposed to be losing my class, but you have that page, it's okay. Do you have the next person to go to the bathroom, Francesca? Scan, show, and go. Throw it up. Are you able to scan, show, and go? Let me know.
Yeah,
Don't forget, afterwards, take the test with you. Okay, so, do you remember your strong acids?
Hydrochloric acid.
That's one of them. HCl, H2SO4, HNO3. These are the ones that Cambridge wants us to know by heart that they will present us with that are formally defined as strong acids. So for any of these, you will need to calculate the pH for these acids. And then what are our strong bases? Just as a reminder. OH minus, but not all OH minuses. Sodium hydroxide is one of them. All group 1 hydroxides are defined as strong bases. It doesn't work? What is it saying?
This one's saying sign in, and I can sign in, and then it just like reloads and says sign in.
Okay.
I gave up on last year too.
Just so I can work on troubleshooting at another time. Today is the 15th.
Thank you.
Okay, so we know the strong bases are group 1 hydroxides. Alkalis are the same as bases when we look at the terminology. So when they say alkali or alkaline solution, they're talking about a basic solution. And then the other thing here, what do those brackets mean? If something is in brackets, that means that it is in mole DM-3. That means that it's a concentration that's being presented to you. And so as we go through, I'm going to remind you of some things because it has been a few months and I'm going to assume not everybody has been diligently working on the summer packet. So I did, by the way, choose the topics on the summer packet carefully for what we would actually be doing in this class. So there's a section that's just on acids and bases. And they would be like, you know, the pre-ACE solving questions. Very similar actually to the homework you're going to receive today. And then it says, define mathematically the terms pH, Ka, pKa, and Kw. Today we're only going to see these, pH and Kw. And next week, Thursday, we'll see the others. Because next week, Tuesday, there will not be enough time to go over that topic. That topic needs more love than the amount of time you'll have on Tuesday. So we'll go over these first. And then notice it says Kv and the equation Kw equals Ka times Kv will not be tested. However, if you were to take a chemistry ACS Olympiad, that would be tested there. That's why they're bringing it up, is that it's something that could show up. I'm sure they do that in AP Chem. They do more formulas in AP Chem than in ACE Chem. Here it's a lot more theory than formulas, but we still have a significant amount of formulas today. Those formulas, you will mostly recognize them. It was a year and 4 months ago that we covered them, so 16 months is a long time, but we have went over most of these before. All right, so let's take a look at that bell work you were all looking at the beginning, and you all did a wonderful job of starting to get into your group, starting to make your plan for when I start giving you those bell works and start putting up the counters, because we will be doing the same thing this year. If you get 12 bell works, you get donuts, and if you get that 4 times throughout the year, you get pizza. Last year, the A-level chem class did it. They did it right on the line. They did it like in May, right before testing, in the last week, but they did it. So, yeah, you did. It was like right at the, you got the pizza.
Oh.
You did.
Yeah, I don't know. Period 4 got it.
Period 4 got it first, yes. And period 2 got to help out this time. get the pizza this time, yes.
Did you get game points again?
No game points. No, that's just a pretty thing.
Oh.
All right, so let's take a look at this bell work. And this is actually a pretty old question. I want to say it's from a 2016, 2017 test, but it's still interesting to look at. So it says using the symbol HC to represent an acid. So this is our acid. It says write equations that show the following substances and how they would act as a base. So they're telling you in both of these equations, this is the base. This is the base. That's what they're saying. And that the HZ is the acid. So then what happens in an acid-base reaction? We got to revisit Bronsted-Lowry theory. Do you remember? Like, no, as soon as the papers were over, I went and I forgot everything.
Mhm.
What is a Bronsted-Lowry acid? Go ahead.
It's the one that donates the H plus.
So donates H plus. That is the definition of a Bronsted-Lowry acid. And then what is a Bronsted-Lowry base then?
OH donated.
Nope.
OH received.
Yeah, H receiver. A Bronsted-Lowry base is the other half of the story. If the acid gives away the H plus, the base receives the H plus. So receives the H plus. So then, okay. How does this give away its H plus for the first equation? Right. So the first thing I would do here is write that as H plus. What's the other part of that? Is H is plus, then Z is what?
Minus.
Minus. We don't care that Z is something random. We have no idea what that is. But we know this in how a minus part. So literally that H is going from here to there. So now what are your products? NH4 plus. And the other one is Z minus. Now in prior years, and I'm going to say this over and over again this year, where the A-level students have faltered that I hope you all won't, is they forget to include their charges at the end. The anion charge and the cation charge. It happens a lot. And so I'm going to be very careful to point out every time this type of thing happens where you have to include charges in your end answer, which is pretty much every chemical reaction where you don't have something that's neutral. And so does this make sense? The first one. Second one's really weird. I thought it was weird. I was stopping it. Because that's alcohol, but alcohol is slightly basic. So how would we write that though? This is again H plus, Z minus, the H goes there.
You get CH3.
So what would that become?
plus Z minus.
CH3, OH2. With what charge? This was neutral. We just gave it a +1. What's its charge? CH3OH2 +1. Because literally you're taking this hydrogen and adding it here. There was already a hydrogen there, so you're adding a second one.
So in this case, you wouldn't like segregate.
You would not, just like the last one, you took that H, you put it there, you combined it with the NH3, you added it. Instead of H3, you put H4. It's literally the same thing that you're doing. You're adding the hydrogen into the other molecule. And then what is the other product? Z minus, yeah. Because they're acting the same way in both cases. Where people get thrown off is, hey, how's that a thing? How is that a thing? I will show you right now. So this is CH3OH, right? How does an additional H plus get there? How does that happen? Safe bond. It does happen. It can happen. How can it happen? This has an unshared pair of electrons that it can donate. So if you want to write that out just to say, hey, yeah, that's the thing that happens, and it's going to have that positive charge because it's an H plus. That's how that works. Like just trying to recalibrate ourselves because it's been a while. All right, so I'm going to pause, give you a little bit of time. And then we're going to get to a little bit more about conjugate acid bases because that's the topic that we're starting with, which was, like I said, welcome back, a topic that we ended with last year. So are we good with this? The ideas here? So we already said this. We wrote at the beginning, acid is proton donor, base is proton acceptor. These are what your equations look like, right? So if we look at our one here, can we figure out if NH3 is a base, what is NH4 plus? An acid or a base? it's an acid. And it's a conjugate acid. Why would we call it a conjugate acid?
Because
It's on the product side. And Z minus, it's a base and it's a conjugate base. So whatever is the base on one side of a chemical reaction, what molecule is a base on one side of a chemical reaction becomes an acid on the other side. Whatever is an acid becomes a base on the other side. We call this a conjugate acid base pair, actually. So if I look over here, HCl, what's the other molecule that would, or the other substance, because it's not a molecule, that would be related to HCl on the other side of the reaction? Go ahead. Cl minus. So we would say HCl and Cl minus is a conjugate acid base pair. So you're going to want to write that down. Meaning we've got the acid version and the base version of that substance. So you may be asked to identify conjugate acid base pairs. Is there another conjugate acid base pair here? Oh, that's my phone. Hello. Hello. Okay, I'm submitting it. I thought I did, but thank you. Should just double check. Okay, so what is the other conjugate acid base pair here, Ramon?
NH3 and NH4.
No, the same equation.
Oh, H2O and H3O plus.
Correct. So another one would be H2O and H3O plus is also a conjugate acid base pair. A conjugate acid base pair is always related by one H plus, the acid version and the base version. The one that has the extra H plus and the one that doesn't. So Ramon, lead off from there. In the second equation, what are our conjugate acid base pairs?
NH3 and H4.
Correct. Acid base pairs. One would be NH3, NH4 plus, base version and acid version. And the other one would be H2O and, wait. Does this topic ring a bell from last year? Good. I was going over, in the summer, I started revising my lessons and adding the questions in, but I always, for every class, both my ACE classes, I'll always solve your lesson the night before, like do all the questions. And then when I was looking at this last night, I was like, just bear with me. Some of the ACE questions, I want you to get a taste of what they look like today. But let's take a look. So we already said what this is, but this is not an ACE question, but I've just defined for you what conjugate acid base pairs are. This is the acid, this is the base. This is the acid, this is the base. I actually listed this one for ACE. I put this in the pre-ACE presentations. But this is your practice question. What would the conjugate base of this be?
There's some,
So this is organic, right? Where's the acid?
the carboxylic acid.
Right there, right? That's the acid. So what was it? If this is the acid, what's the conjugate base first? What would you do? Remove the hydrogen, right? Take a look here. The acid always has one more hydrogen than the base variant. So if I'm asking you for the base version, I'm asking you to take away one H plus. So then how would we draw this? This is the drawing. Terrible. Well, I'm drawing it terrible. And then what? Go ahead.
CO2.
CO2. But if I wrote CO2, would I get the mark?
No, that's not.
I mentioned at the very beginning, charges is what destroys the A-level students. When the H plus is taken away, what's left over is CO2 minus, because this thing started out neutral, right? So this is CO2 minus. Does that kind of make sense? Yes.
What do we, for the minus?
Right after the CO2 at the top corner.
Okay.
Or if you really want to, you could draw out the CO2, but usually for Cambridge, it's best if you give your answer the way that it's presented to you. Don't try to overcomplicate it. Yes.
Does was it called putting parentheses around the thing and then putting a
Well, you
minus?
put parentheses around it. So like you're saying to do this. Still terrible drawing on my part. So CO2, right? And then do this and do minus.
Mhm.
Same thing.
Okay.
Because the whole molecule, has that negative charge, making it an anion. So it's the same thing as this. Your choice, what you want to do. But you have to include the negative charge. If you don't include the negative charge, it's just wrong. Because you're getting rid of the positive. It started out neutral, so it must be a little more negative. All right, so here I said we had a Cambridge question coming up. Paper 4. Some solid calcium is added to an excess of aqueous ethanoic acid and left until they did not. It's like it's not a C day today. I'm like, how did this happen? How did I just start the lesson? No, we're good. I'm like, we didn't even start a pH formula. We didn't even say negative log H plus. What the world? We're about to get to that. What?
I think I just thought I heard. I heard.
Yeah,
something.
the speaker was on for a moment.
That's outside in the hallways.
Oh.
Got it. All right, so we've got calcium.
Please pardon this interruption. Please disregard that bell. We are on a 135 block schedule. Please disregard that bell. 135 today. Thank you.
Some solid calcium is added to an excess of aqueous ethanoic acid, which they gave you the formula for, and left until all the calcium has reacted. The resulting mixture, mixture D, has no undissolved solids, meaning everything has dissolved. Write an equation for this chemical reaction. So what type of reaction is this? Sure. And so how would you complete it?
Calcium plus OC3COH.
Plus what? Oh, okay. You're already balancing it. But what would we do before balancing? Technically, what should we do first?
The charges.
Okay, the charges. What are the charges? Calcium is going to be positive, but positive what?
One.
Calcium is supposed to have a +2 charge in a compound.
Oh.
How do we know that?
All periodic tables.
Oh my gosh! I think you all need periodic tables.
Yeah.
If you can't see the one on the screen.
What do you do?
Here you go. These out.
Miss, what are you planning for us to have now? And then like give us periodic table like that? She just forgot to hand out the periodic.
Passing out this for your table. These are your new periodic tables for your tables.
You should have had Stefan do that.
Oh, yeah.
Really?
Yeah, they're different colors. Here you go. You need a periodic table for this, don't you?
With a change.
Why don't you? Oh, wait.
What? With the
No, never mind.
Hello. Here you go. Here you go.
hey, you
All
want
right.
to change?
So you can see we have laminated periodic tables. So how do we know that calcium plus 2 charge. Periodic table, it's in group 2. Perfect. All right. What else should have charges here?
Voice too.
She does.
What are the charges?
0.
I heard plus and minus. Okay, what's the plus part?
It should be minus because hydrogen leaves.
Which part is minus? Which part is plus? Is my question.
Oh, hydrogen is positive.
Okay.
H3COO it's negative.
All right, that's a good. We're starting to map it out. So we know that we have calcium's plus 2. We know that we have CH3COO is minus 1, right? That's its charge. And we know that we have hydrogen is plus 1. Good so far? Okay.
Amy's question, should we put the charge in because I mean it doesn't have a charge yet.
So notice how I did not put the charge in calcium here. This is a great question. Calcium in its elemental form does not have a charge. Do you remember that?
Yep.
Calcium will only get a charge when it goes into a compound. And so this is a type of reaction, what I asked a little bit earlier, you said acid base. What classic reaction is it that we may or may not remember? It's actually one of the Prius reactions.
The single replacement.
It is single replacement. So this is actually A plus BC, right?
I actually kind of forgot that it could be as simple as single replacement.
It's one of those things that happens the more that you learn, the more it gets confusing. Because you're like, we learned this reaction, we learned that reaction, but yeah, this is just a single replacement reaction. It looks a little bit more complicated because of the organic stuff going on. It's never completely going away. It'll be around, even though we're not actually going over organic yet, it will be around. So, now what?
This one, A goes in.
So, this is a cation or an anion? Cation, when it goes into a compound. So it's going to switch with what?
Oh,
It's going to switch with the H, right? Because cations replace cations. So that's something that I have to review, right? Cations replace cations. That means the positive charges are going to switch out. So now that means hydrogen is going to be by itself, and calcium is going to go in a compound with CH3COO. But knowing that calcium's plus 2 and CH3COO is minus 1, what is the compound?
calcium, H3.
And I would do it on the side. I would not do it in my final answer area. This is what I have, right? What does that become? Because it's not one of each. And they do throw you off, and they might do this like they did it on paper 2. They'll definitely do it on paper 4. These don't automatically cancel. What does it become? It's Ca, CH3, COO, 2. 1 and 2, right? 2. And the other product? H gets kicked out, right? So we're doing this thing. Here we're doing A switched with C, right? So it's going to be, we did AB in this case, and we're kicking out C, which is hydrogen. That's what's getting kicked out in this case. So how does hydrogen get kicked out?
H2.
H2. Because it's elemental. It's a single element. It's no longer part of a compound. When elements are produced, and so this is something that we learned all the way back in Prius chemistry, that I'm gonna go, I have the time to go slower over it now, so I am. When elements are produced, they are always produced in their, correct, they are produced in a standard state. And these are little things that you do not want to forget. So it's going to be H2. Do we have the point yet? Hello. For what? Okay, Stefan, Ms. Haran would like to see you. Knock on the door when you get out. Okay. Good so far? Do I have you, are you following me? With what I've done? Question. Why did I put this in brackets? I put it in brackets because it counts the same as any other polyatomic ion. Is that true? Is that something that registers? It's multiple atoms that have a charge.
Yes.
So it's technically a polyatomic ion. Yeah. I see questions. I'm glad. Ask them. Because this is stuff from the past actually. But it's important to know. Yes.
How does the hydrogen form if they're both, they both have a positive charge?
What do you mean?
If we have two hydrogen, two protons.
Because
those
the
protons
electrons from Preston.
they take the electron from the
So yeah, what's happening here? This goes 0 to +2. This goes +1 to 0. This is redox. It's redox. Redox is in your summer packets, I believe, and it's our unit 3 in this class. But yeah, that's why the electrons are transferred. But are we okay with the type of reaction? Like what to do here? Any other questions? I'm good to move slow here. Okay, so we're not done. We don't have 1 point. What are we still missing? Balancing. We haven't balanced it. So when we write an equation, you must always balance that equation. You must always balance that equation. Okay. Cool. So how we do that? I see I have the 2 of the organic, right? So that means I need to have a 2, right? Here. Doesn't that also fix the hydrogen? I have 2 hydrogens here, so this is 2 H's, right? That's it. Didn't you wish balancing is always that easy?
Like question number 1 of the exam.
Right. All right, I think it took me like 10, 15 minutes to solve that. No, maybe 5, so it felt like a long time. All right, that was 1 point. So why is this 1 point so much? Well, it's literally just a cycle replacement reaction. That means that's an expectation that you know how to do that. If you practice it, it isn't so much. It's just one of those things that it looks harder because you've got so many atoms going on, so it's identifying all the important things and completing the reaction type. Yes.
So we have to put the charges in the box.
You don't have to put, you shouldn't put the charges at all. So that's why you notice that I put the charges on the side over here. This is me just proving what's going on, but in your final answer, your charges shouldn't be there because the charges always cancel out to make a neutral compound. All right, 2 more marks here. Use formulae of molecules and ions to identify 2 conjugate acid-base pairs present in this mixture, in mixture D. What is our first conjugate acid? Looking at this reaction. Can you see a acid and a base pair? What is a conjugate acid base pair again? Conjugate acid base pair. I think their wording here is awful, by the way, and sometimes is on paper 4. The wording here is awful, and I'll explain to you why. But conjugate acid base pair are 2 species that differ by 1 H plus. By 1 H plus, right? Okay. Meaning the acid version and the base version. Can you find an acid and a base here in this reaction? There's one that's staring at you.
The acid CH3COH.
Yep. And its base is?
CH3CO.
That's one of the 2 marks.
Then the other, the acid, like the H2, and then the base would be CA.
Doesn't fit. The reason why, welcome back. Are you still in this office? James? Okay.
Hey,
This is
I
a
said H2,
what H2 what?
H2, and the H is a CH3, COH.
Let's see. H2. Nope, calcium's not an acid or a base. Okay, so why, and I was like, why did I start with this question when I was solving it last night? Because there's a lot of explanation has to be done for this. So this question is what I would call ambiguous. What does that mean?
Wait.
They're asking you to think outside the box. There is no other visible acid-base pair here. Would you agree? Because an acid and a base, like calcium doesn't have a CAH or a, it doesn't have one more H. It doesn't fit what a conjugate acid-base pair is. So where in the world, if we know that this is acting as an acid, what is technically something that could be acting as a base? What did I hear?
Oh, eight.
H2.
So what you're maybe not recognizing, ethanoic acid base.
Water.
That water is here. And so it's in the mark scheme. The other acid-base pair they wanted you to recognize is that another conjugate acid-base pair could be water and OH minus, or H3O plus and H2O. And so how do you get that? Because aqueous. It didn't actually show up in your equation, but water is there and readily able to receive and give away hydrogens. And so, yeah, I would expect that on an actual Cambridge exam that would be what we consider to be a little bit of a tough question. Not all questions are like that. And I would expect that you'd be able to pick up this one, but maybe not this one. Because it's like if you read that word or not. If you didn't read that word, you missed that.
It's only one.
It's only one mark.
See, that's gonna be the difference between A level and A star plus.
All right, so now that I, started talking about like getting you back in the mix and you're like, oh my gosh, it's been 3 months and we have to go over all of this. We're gonna head back to something called pH. And so a long time ago, we talked about what pH was, and that it's actually a scale. One of the things you need to know about what we defined as neutral is, and this isn't going to change, neutral pH is always when your amount of H plus equals your amount of OH minus. That's still the same. It's always the same. At 25 degrees Celsius, standard conditions, this is the pH scale.
So temperature affects the pH level?
That'll come later. At a standard temperature of 25 degrees Celsius, this is the pH scale. But yes, pH can be affected by temperature, and we're going to talk about how that happens later if we have the time today. If we don't have the time today, we'll do it on Tuesday, which is why I said your homework wasn't going to be due until next week. Thursday. Give a little bit of time. And then you can see here that they're saying H3O plus. Do you remember last year I told you that H plus was the same thing as H3O plus? Cambridge will use them interchangeably, and so will I. I'm a little lazy, so I prefer writing H plus because it's less. But I understand the reasoning for writing H3O plus because water is involved. It's always protonated when it's acid, meaning it's always got that extra hydrogen. So just important to know. pH scale goes approximately from 0 to 14, but there are arrows both directions. So can pHs exist below 0?
Yeah, yes.
Yes. And what does that mean?
The cumulative square, that's it.
It does. That is exactly what that means. Does it mean you want to touch that with your bare hands? No, you don't. So then formula number 1, and you are going to have some formulas today. This is a new one. So the first major formula is called KW. KW. All right. Before we get into it, what is capital K? You know, it can capital K with a little thing underneath it, with a double arrow. With a double arrow, it's equilibrium. So K with like whatever down here, like KA, KD, KC, KW, K whatever, is always product over. Yeah, we call this our equilibrium constant. So let's take a look at this. What is the state of matter for water? Liquid. Fill that in. What is the state of matter for the other waters? Solid. What is the state of matter for H3O plus? Aqueous. What is the state of matter for OH minus? Aqueous. This is the autoionization of water. What in the world? Those are big words. Water, when with other waters, will self-ionize, meaning one water molecule give away H plus, and another water molecule will receive H plus, which is one of the reasons we say that water is amphoteric. It acts as both an acid and a base. Go ahead, Ato.
Just as a reminder, the equilibrium is like molarity or what over like
It is molarity for the units. The units for KC are in molarity, and then we may have to actually solve for the actual units as we go along.
and molarity is mole over dm3.
Mole over dm cubed. Yes, we haven't gotten to that part yet. Yeah, yeah.
How would that equation work? It would be like it doesn't make sense to me. Like water with water, and then it just not happen.
So H, O, H. Lewis structures are always the answer if you need to explain something. Plus another H, O, H. There is a very, 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 very small chance at standard temperature, about 10 to the negative 7. That's 0.000001 moles of water will do this. So not very much. But this H will actually break off and be like, hello, and go over there and make a dative bond to over here. It'll connect, and it's actually going to go, if I show my arrows properly, which I didn't, what's going to happen is the oxygen will take this hydrogen, right? And then this will go there to make the OH minus. That's called a mechanism, right? With the arrows showing what's going where.
Under like certain conditions.
But really it proves what's going on. What's going on, this is taking, this is becoming OH minus because we're taking away the H from here and we're transferring it here. And this becomes H3O plus at the end.
Wait, does this data flow?
Technically, it's a dative bond, yes. It's a dative bond to get the extra H on. Literally just an H is jumping. In this one that's shown here, it's going from here to here. Like hydrogen going up like that. One hydrogen. It's transferring from one water to another. So you add a hydrogen to this one and you take a hydrogen away from that one. And that's how you get these two products. Does that kind of make sense so far?
Yeah.
All right. It's actually not the question I had. The question I had is then, given that this is aqueous and this is liquid, what would this formula be for KW? Could you figure that out yourself? Maybe. You may or may not recall that liquids and solids don't count in equilibrium expressions. Do you remember that? Make a note if you don't, right? Liquids and solids don't count. That's going to become really big for an entire lesson later on in this unit called KSP. Liquids and solids don't count, which means, does anything on my reactant side count? So that's actually, you can cross that whole thing out. So your KW is just your products. So your products here would be the molarity of H3O plus, molarity, that's why brackets, right? And then multiplied by the molarity of OH minus, because in equilibriums, it's always multiplication. Always. So KW is H3O plus times OH minus. KW is a constant at standard temperature. It is 10 to the negative 14. So it's actually a constant. And so you can fill that in. 10 to the negative 14 is H3O plus times OH minus. I give you periodic table. You're gonna keep these at the table. This is for your daily, class. You're getting another one, but it's not colored. Sorry, you're getting another one, but it's not colored. I did something. Flip to the back. These are the constants that are provided to you on paper 4 and paper 2 and paper 1. Can you find this? KW on there? It's there. KW is called the ionic product of water. It's 10 to the 1 times 10 to the negative 14, which is the same thing as 10 to the negative 14 with the 1 in front. And then they told you the actual units for the molarity times molarity, which is mole to the minus 6. We'll practice with how to get units later on, but that's literally, this is a given. This is given information to you on the test. So just FYI, every time there's something that's on there, I'll point it out as we go through. So you know what you need to memorize, what don't you need to memorize. But what you need to know is that is the ionic product of water, which means you're multiplying the acid times the base. 10 to the negative 14, does that have any relevance to us? Is that relevant to us in terms of acids and bases? Does that number matter, the 14? That's literally what the pH scale is based off of. The pH scale is based off of KW. Actually, that's how it is derived. Yes?
Wait, sorry, I wanted to ask, why is it, why are the reactants crossed out as 1? Shouldn't it be 0?
No, it's 1. When they don't count, it's 1. If it's 0, all your answers are undefined all the time. It's 1 meaning they just don't count. 0 would mean don't exist. Very simple. Like, it's 1. All right, so let's hear Formula 1 that you have to know for this class. You could be asked to literally define KW. So if they ask you to define KW as the standard, you literally write this and it's worth a point on a Cambridge exam. The same points as before that. As usual, Cambridge exam questions can be easy or they can be difficult. What I noticed about the A level in comparison to the AS is there are actually more definition questions on the A level. So they'll literally be like defining things. All right, so Formula 1, define, this is the definition. KW is defined as H3O plus times OH minus. The acid times the base. And so today's goal is to do pH calculations. We're going to get as far as we can. Hopefully we can do the standard formulas. The lower the pH value is, the stronger the acid. There was actually, and I think Cambridge was a little bit spicy for this. In your paper 1, they literally put something like this in your paper 1 on the first couple of pages where you had to recognize the lower the pH value is, the stronger your acidic solution is, and the larger your concentration of H plus ions. So and we have said that before. As we go this way on the pH scale, your acids are getting stronger. This means you have more acid, more H plus ions in your solution. And so this is important to note. This is your first real formula. Well, second formula number 2. You may or may not remember it. You saw this in previous. This is the calculation of pH formula. If you want to calculate pH, you're going to need to remember you will absolutely, unless you have log 10 tables memorized in your head, you will absolutely Or you have, there's actually, for those of you who are good at math, if this is like 10 to the second, it's easy. But otherwise, you need to have a calculator to solve these. So this, you need a calculator. So that's why you needed a mouse today. pH is defined as the negative log of H plus. P of anything is the negative log of that thing. You may want to write that down. Because back in pre-ACE, I gave you a second formula. May or may not remember. I said you could do P of the OH. You remember that? And what was it?
Negative log.
Negative log of the
Always minus.
OH. And you're going to see other P. You're going to see another P in this class. And it was on the lesson slide in the objectives, pKa. Every time you see that little P, it's literally the same thing. Negative log of whatever that thing is. So P of whatever is negative log of whatever that thing is. And so the first one is pH is negative log of the H plus. Your calculator is already base 10, so you don't have to do any change of base. For those of you who remember that was a thing, you will not have to use change of base here. It just is directly to your calculator. And so we're going to get started. Take some pHs. Negative log, 3 times 10 to the negative 4. Negative log, 1 times 10 to the negative 2. And negative log, 5.4 times 10 to the negative 12. So for the first one, it would be pH equals negative log 3 times 10 to the negative 4. See if you can put that in your calculator and get the answer. And I solved this all in advance, so I'll just check.
Replay.
3.52 is right. Did you get that? For the second one. The answer is 2. Or 2.00 for some figures, right? And the third one? 11.27. Which of these is the strongest acidic solution? The second one. And what is the strongest base? Right? So all the numbers in this class will carry meaning in terms of when you get a pH of this value, you can interpret that, whether it's strong. So this is the strongest acidic solution here. The pH is the lowest, and this is the strongest base or alkaline solution of the 3 that we're comparing here. This formula rings a bell, right? For most of us. We did it not last year. We did it in pre-ACE. It was in Unit 7 pre-ACE. Anybody need help with putting in the calculator?
Just like exploring whatever we like to do.
Oh, I see. Wait. I see a 10 to the X there. But I don't know. So I do like here. So you have to do shift and then that 10X button. All right. Yeah. Okay, leave it on the side and I'll clean it up. Was it broken by you? No.
Still there.
Do I need to reset that counter?
Up and do it, break something?
They said we found verse one. All right, moving on. pH of strong acid. So just because you have a strong acid doesn't mean that the solution is going to burn through your skin, because something called concentration matters. HCl is also gastric acid. That's the acid in our stomach. So yes. Is there any left in the bingo marker?
Yeah.
Okay. So take a look at this. Point with molarity HCl. If you take the negative log of that, what's the pH? Do the same thing for this one, and the same thing for this one. You get 1. The second one? 2. The third one? 3. Do you see a pattern? The pattern is the greater the molarity, right? So the greater the molarity, which Cambridge just called concentration, right? The pH. The bigger the value of the molarity, what happens to the pH? The lower the pH. So when I'm in the laboratory, if I see a container and it says 0.001 HCl, am I really that concerned? No, pH of 3. pH of 3, other things like, lemon juice has a pH of 3. Citric acid generally has around the pH of 3. Yeah, it's going to sting, but let's say that I see a container that says 10 molarity HCl. What would that be? If I had a container in my lab, which I do, but not in this room, what's the negative log of that? Take the negative log of 10.
Oof.
What'd you get?
-1.
My pH of that would be -1. Under 0, yeah, that is going to sizzle through my hand and burn through my skin and leave a permanent mark. I'll probably start screaming and crying. But and that's why I know when I'm looking at something, I'm going to be wearing my gloves, I'm going to be wearing my goggles, I'm going to be wearing long sleeves, right? To make sure that, I'm as safe as possible. All right. So does this make sense that the greater the concentration, the lower the pH, and this really communicates the strength of the solution, the acidic solution. And so when you're in a lab yourself, which won't be too long, within the next couple of weeks, you'll have your first lab. Look at your labels, is what I'm telling you. Look at your labels. All right, next thing. Calculating H plus from pH. You may or may not remember in pre-X, I'm going to say this a lot because this lesson is actually straight up from pre-X almost. You may remember this formula. It was the opposing formula to the logarithm formula. 10 to the negative pH would give you your H plus concentration. You would just put 10, you would raise it to the negative pH in your calculator, and you would straight up get how much acid do you have. We did this formula in pre-X. So what I'm going to show you now, first of all, I know that in this class, we are of various mathematical abilities. If you don't love math, you could just straight up memorize this. It's good. It's all good. Just memorize the formula. I told you to do it in pre-X. But if you do like math, you can derive this from the pH formula. So let's figure it out. So I don't always say this, but if you know you don't love math, you can tune me out quietly for the next 2 to 3 minutes. Everybody else who does, that means if you're in ACE math now or you took it already, tune in. Tune in. You can actually manipulate the pH formula to solve for H plus. How can we take this equation out of log form? Do you remember how to go from logarithmic to exponential form? This is something that you should have learned in a math class.
I forgot.
Logarithmic to exponential form. All right, so I'll write it out if you need me to. It is log A B equals X. So then it would become A to the X equals B. How many of you have seen this? Raise your hand if you've seen this formula. So we're batting at about 60%, maybe 70. Okay, so you've seen this formula before. If you know this formula and you're comfortable with it, the log formula for pH is going to be the same thing. So first of all, let's take a look at this with just math, like I'm a math class right now. I've got log 3, 9 equals 2. How do I change that to exponential form? So change to exponential. 3 to the second equals 9. You can always do something like this to prove whether you got it right or not, because that makes sense. 3 times 3 equals 9. This is the equivalent statement with a logarithm. With me? And if you're not, I told you to, if you want to do 2 and out, I'm okay. Like I said, I'm okay with that. Just memorize the formula. But for those of you who are math oriented, actually like myself, I prefer having a method, like memorizing the least amount of formulas and then just being able to manipulate them with my mathematics. Because I was really good at math, my physics and chemistry courses became significantly easier because I could just like math. Math is important. I could just math out how to do it. But if you don't love math, you just have to memorize the formula. That's what it turns into. All right, so how do we do this? Let's try that with the pH formula. First of all, I would rewrite it. I would switch the sides. I would write negative log so I don't get confused. 10H plus equals to pH. So it looks the same as this thing, right? So I just switch my sides because they're equivalent. The next thing I would do is get rid of what's in front of the log. What's in front of the log? Negative. So I would divide both sides of the equation by -1. That turns this to log 10H plus equals negative pH. Following me still so far? Remember to ask questions? Yes, who do you need? I do. Sophia. All right, she's coming out. Good to run?
Yeah.
All right, now I've prepped this. This is in the correct form. I can now change to exponential. So what happens? You drop the log. You do 10 to the negative pH equals. Basically, these two just swap and you drop the log. And it becomes 10 to the negative pH equals H plus. And there it is. That's the other formula. It's literally the inverse. Like, one's the exponential, one's the logarithmic form. And it solves for the other thing you're looking for. So the second formula, Luke. The second formula, or formula 3 technically, is this one. It's if I want to solve for my acid concentration, I'm going to need to plug in my pH. So this is I'm given my pH and I'm solving for H plus. Remember how in previous I would tell you we had our givens and our asked for. Our given here would be the pH and we are looking for H plus. In all the other questions, I gave you the H plus and I asked you for the pH. So now we're doing the inverse, the opposite. Yes? So pick whether you're going to do just memorize it or the other way where you create it. You could memorize it, but then have the other, ability at your fingertips just in case you want to make sure you remembered it correctly and be like, oh, let me see if I can map it out. Is that the right formula? Calculate. So, calculations. How do we calculate the concentration of hydrogen ion, H plus, or H3 equals the. In solution to these values, pH of 2.9. So what would we do? I gave you the pH. I want the acid concentrations. What do we do? Apply the formula we just did, right? So 10 to the negative pH equals our H plus concentration. You know what? When my PowerPoint goes on the fritz, I don't have to stress if I'm second period because I don't have to teach a fourth right after. I can just save it and go back. Makes life easier. Because I have to delete everything. I had to delete everything last year. So sad. pH to H plus. So what would you do? 10 to the negative 2.9 equals H plus. Put that in your calculator. That's it. You cannot leave your answer as 10 to the negative 2.90. That is improper formatting. You have to put this into your calculator. What do you get from that?
I just made a stupid mistake here.
0.001258. I would do 0.00126.
You don't have to like use the 10 to the power of negative like 4 or something like that.
It's a great question. You are allowed to use scientific notation or standard format. I would say after the third or fourth exponent, I would switch over to scientific notation. That's how it is on Cambridge mark schemes, but they would absolutely accept this as a response. So I'm going to put or 1.26 times 10 to the negative 3, like that. All right, so pH 3.7. So that's 10 to the negative 3.7, right? And so what does that equal? 10 to the negative 3.7 equals H plus. So this is going to be, my calculator just gave me 2.00 times 10 to the negative 4. Is that what you did? I got 2.00 times 10 to the negative 4 equals H plus. And then 12.9. Your calculator will switch over to scientific because it is not going to write that many zeros. So what do you get for this one?
1.26 times 10 to the power of negative 30.
Right. And
I chose this one, so it's okay.
do you remember doing C grades?
Let's say negative 13.
I got negative 13. I got negative 13, yeah. All right. So I think, let me look at our time. I think this is going to be our last question for today, the next one. And then after that, we'll do your workbooks. All right. So the next question is going to be our last question for the day. On Tuesday, we're only going to do the finishing of this when the seniors are back. When the seniors are back in the last part of class, we'll do the finish of this lesson, but we will not move on to lesson 2 until next week, Thursday.
Okay.
I expected that. That's why I already said your homework is going to be posted to be due on Thursday. So this is going to be our last question. There's one more thing you could be asked. What if I gave you the acid concentration and I wanted the base concentrations? You can go back to equation 1, which we had said was Kw equals H3O plus, so this is where I don't want you to get confused, times OH minus. If I'm at room temperature, or standard temperature, my Kw is 10 to the negative 14. Notice here I wrote H plus. I told you this was going to happen. You're either going to see H plus or H3O plus. It's the same exact formula, either way. So 10 to the negative 14 is H plus times OH minus. So if I want the OH minus and I have the H plus, how would I solve? What if I want to solve for OH minus? What would we do? algebra, right? We would do divide both sides by, so I'm gonna write that over here. 10 to the negative 14 equals 8 plus times OH minus. I wanna solve for OH minus, so I'm gonna divide both sides by. So it would be 10 to the negative 14 divided by H plus will give me OH minus. If I was looking for H plus, wouldn't I do the exact same thing but opposite? So it's always going to be 10 to the negative 14 divided by acid if you want base, divided by base if you want acid. This is based off this formula. So this is your first formula, and the last type of question we have to solve is going to be based off of this formula. I'll pause. We can use this to calculate pH, strong basis. We're going to do one practice question like that. Then we're going to stop for the day so you can get your workbooks for the end of class. Because this is a multiplication. We would do a division to solve for it. Yes.
Why is KW?
That is the autoionization constant of water at 25 degrees Celsius by definition. Like every chemical reaction has its own K. You may remember equilibrium constant. That is that equation's equilibrium constant. It happens to be where the pH scale is derived off of. Yeah. Hi.
Because it doesn't mean that on water has that concentration of.
At 25 degrees Celsius. That's why do I keep saying this? Later on Tuesday, I'll explain why. All right, so last question for the day. Then I'm going to talk and share with you about your workbook. Find the pH of this. 0.5 molarity NaOH. Is this an acid? No. This is a strong. This is a strong base. Strong base. Okay. What does that mean?
We're looking for
What is this the concentration of? Is this the concentration of acids? No. What is it the concentration of? It's the concentration of NaOH.
Oh.
What do you need to get first? So I got some steps for you.
oh man.
Step 1, find your OH minus concentration. You may intuitively know what that is. What is the concentration of OH minus here?
0.5.
And how do we know that is true? Because it is true.
Because there's only one mole of hydroxide and sodium hydroxide.
It's 1 to 1, right? Which means if there was a 2 OHs and you'd have to multiply it, right? Thankfully, your strong bases are pretty much group 1, so it should be the same. So find OH minus concentration. It would be 0.500. Are we okay with that? That is the same number. All right, what happens next? I'm looking for pH. What can I do? Technically, according to the formulas they've provided for us, I cannot get pH off of OH minus. I have to get pH off of what? H plus. So my second step would be to find H plus. What formula would I use given that I have the OH minus? Formula 1, right? So that's the one that's 10 to the negative 14 equals H plus times OH minus. We have the OH minus. So 10 to the negative 14, H plus times 0.5. Now what?
divide by
Divide by 0.5 on both sides, right? Which I said you could just skip the step and just remember it's 10 to the negative 14 divided by the one you have to get the one you want. You don't have to show all this work for Cambridge. They actually assume you know how to do this. So you can skip that step in the calculator. But you get what? 2 times 10 to the negative? I get 2 times 10 to the negative 14 equals 8 plus. Are we good with step 2? What is my end goal here?
pH.
pH. So how do I get there?
Negative dot of H plus.
If I've got pH plus, to find the pH is formula 2.
Turn minus.
So pH equals negative log of 2 times 10 to the negative 14, which equals 13.7 is what I get. So check your answers to see if you get the same. Raise your hand if you have any questions. Otherwise, we will start switching gears. I'll stop recording at this time.
Oh, I probably should have told Miss Ledesma and Mr. Garcia they were being recorded, right? Because they were in here. No,